Welcome back, guys. For the next part, where Fnet equals ma, we're going to consider multiple masses. And these are really common on AP problems. So it turns out that if you have a net force and you have multiple masses, that the masses will have to share this net force. And they'll get the proportion of that net force that's proportionate to their mass. It doesn't matter the order that they're in. So in this case, this is a 2 Newton force, or 2 Newton block. It has a mass of 0.2 kilograms. This is a 5 Newton box. It has a mass of 0.5 kilograms. So this total force needs to accelerate 0.7 kilograms together. So those two together would be 0.7 kilograms. The amount of force that the 5 Newton one is going to get is going to be its mass divided by the total mass. So it's going to receive 5/7 of the tension, because this one is going to use up 2/7 of it, and everything needs to be accounted for. All right, so I have two free body diagrams. I'm going to call this block 1 and this block 2. I'm also going to have two tensions. So mass 1 is pulled to the right by T1. It has a weight going down and a normal going up. Mass 2 is pulled to the left by T1 and pulled to the right by T2. And this should be longer, maybe not that much longer. But I know there's an unbalance because we're accelerating. This should be a mass going down of m2g, and this would be normal going up. Each one of these is going to have its own equation. For mass 1, Fnet is going to be equal to m1a. And I'm going to do rights minus lefts. And so it's going to be T1 is equal to m1a. For mass 2, I'm going to have Fnet equals m2a. And I'm going to do right minus left. T2 minus T1 is equal to m2a. If you look at the equations on top of each other, you could see that one of them has a positive T1 and one has a negative T1. So if I add these two together, T1 is going to disappear. So I have T2 minus T1 plus T1, which is just T2. And I have M1A plus M2A. I can factor out an A. And then divide by the masses together. So my total force is this T, which we said was 4. And then I have 0.5 kilograms plus 0.2 kilograms. So 4 divided by 0.7. 5.7 meters per second squared. I can then plug this in here to find out what T1 is, or I could plug it in here to find out what T1 is. It's easier if it's just T1. So I know T1 equals M1A. So T1 is going to be equal to 0.5 kilograms times 5.7 meters per second squared, which is 2.85 meters. All right, what did I say it was originally? I said it was 5/7 of the total force it was going to get. So what is 5/7? it is 0.71. What is 2.85 divided by 4? 0.71. Oh, no newtons, just a ratio. All right, so if we have pulleys, it gets a little more complicated. Just like Galileo used inclines to study acceleration, we can use pulleys to study acceleration because you can really slow down gravity if you have two masses that are real close to each other, pulling on either side of a pulley. But because of this, because the pulleys change the direction of the forces, we can't have up minus down or right minus left anymore. And so what we do is we pick a direction to be positive. And it turns out that in physics, we take counterclockwise forces to be positive forces. For now, our pulleys are going to be massless and frictionless. When they do end up having mass, we'll deal with that in a later part of the year. We're also going to consider our rope to be massless. And for the most part, compared to the masses we're going to be accelerating, this is true. The pulley is very light. The masses are very light. All right, so I have three masses. 1, 2, 3. And I'm going to take forces that would turn my pulley counterclockwise to be positive, or anti-clockwise if I was in Britain. So let's do our free body diagrams. For number 1, I should have M1G and T1. All right, I know that this is going to go this way, so this one needs to be longer than that one. So I'm going to make it so that is so. For number 2, I need to have a T1 that's the same length as that one. And then number 2 has two things pulling it down. There's another rope, so it's going to be a second tension, and it has its weight. And I think I've mentioned this before. I don't like the dots when you have forces parallel. You can't put them end to end. They have to be side by side. So this needs to be M2G and T2. And these two together should be longer than that one because the net thing that's going to happen is I'm going to have clockwise acceleration. I'm back. They were sanitizing my room. All right, and then for the third one, this one should have the longest weight one, so I need to be longer than that one. And then I need to have a T2 going up there. That's equal to this one, but in opposite directions. And each one of them is going to have its own Fnet. Why don't I switch that first one to blue so we can each give them one of their own colors. So for 1, I have Fnet equals M1A. This is going to be the accelerations for this mass. And I'm going to take counterclockwise minus clockwise. So counterclockwise for this first one, this force down would turn this counterclockwise. So I'm going to have M1G. The tension goes up. It would turn this clockwise. It's going to be minus T1. That's going to be equal to M1A. I'm going to do the same thing for mass 2. I'll switch the pen color so we don't get confused. Now we're going to say that Fnet equals M2A and I'm going to take counterclockwise forces minus clockwise forces. So I'm on this side now. A force up would turn it counterclockwise. So I'm going to say T1 minus M2G minus T2 equals M2A. Then for our final one, which is green, I'm going to say that Fnet is equal to M3A. And again, this force is up. It's going to turn this counterclockwise. So when I do counterclockwise minus clockwise, I'm going to do T2 minus M3G is equal to M3A. And if I put these underneath each other, we're going to see the same thing we saw when there was 2. That we're going to have some tensions that cancel. So if I add these together, I'm going to have a negative T1 and a positive T1. The T1s go away. T2 and negative T2. The tensions are internal. They disappear. And so I have M1G minus M3G minus M2G is equal to M1A plus M3A plus M2A. I'm going to factor out an A. And I'm going to stop here for a second and consider what the second law is. The second law says Fnet equals MA. What is M? M is all of the masses. They all need to be accelerated. So this is all of the masses times the acceleration. What's Fnet? Fnet is going to be the sum of the forces. And we have M1G trying to make it turn this way, and M2G and M3G trying to make it turn that way. So these are our Fnets. If I divide by the masses, and I can substitute it. So this is going to be 5 times 10 would be 50 newtons minus 60 newtons minus 20 newtons divided by 5 plus 2 plus 6. So I'm going to have negative 30 divided by 13. And why is this negative? Not because the acceleration is to the left, not because the acceleration is backwards, not because the acceleration is down, but because the acceleration turns the pulley clockwise. And if I wanted to, I could go in and find out what all my tensions are by substituting back in. But when I do, I'd have to substitute in this acceleration as negative.